So we're doing a graphical user interface, and they actually have lots of code involved. It's considerably more than what our short assignments usually look like. Go ahead and go to the news for our class. Refresh it. You should see an attachment that's got our starting point code. Go ahead and open that attachment. Highlight absolutely everything. Control A is a good way to do that, or Command A if you're a Mac user. Then File, New File, paste, save as GUI1 because I'm sure we will make GUI2s and GUI3s and so on. So if you just walked in, go to the news of our D2L, our front page. There's the source code. Open that up, copy it, paste it into a new idle document. New Python document. Let's take a look at it. It doesn't do very much right now. That's because there's a lot of stuff we have to fill in, but there's a lot of code. It creates a list. Well, the first thing it does is it imports something called tkinter, which stands for Toolkit Interface. There's more than one graphical user interface library for Python, but this is the one that ships by default with it. It creates a list of names. It declares that up at the top. This line we can delete. You don't need that line. I don't know why I left it there. It's nothing, so goodbye. All right, then there are some methods for manipulating the data. I actually meant to say data replace, data delete, data add, rather than list replace, list delete, and list add, but we'll just leave that alone. The way this is going to work is delete's just going to remove the specified value from the index at that index from this data list. Add is just going to do a dot append on it, data dot append. Why are we making these all fancy and put in their own methods rather than just calling data dot append right where we need it? It's to hopefully make this a little bit more structured so that the pieces of it fit together and more clearly in our mind. Now scroll on down to the very bottom. We'll see something called Make Window. This is the guts that actually creates the user interface. And it's complicated. Graphical user interfaces are always complicated. Some tools let you draw your graphical user interfaces and they hide a lot of the complexity. So what we're seeing is that this creates a window. Window is equal to TK. That's kind of like our turtle equals new turtle business. And then it creates what are known as frames. Frames are sections of the window. The top frame is going to have the word name in it. Then it's going to have a place where they can type in the name. The next frame is a rectangle that contains all of our buttons. Add, update, delete, and load. The last frame is going to contain a scrolling list box of that data so that we can select a name and delete it from the list. Or so we can change the value of it. So notice these are kind of like the most important things right here. When you create a button, you attach it to a frame. You give it some text. We're going to see that we have 4 buttons on our screen named Add, Update, Delete, and Load. And then we give the functions they're supposed to call when you click on that button. So in Dr. Byers' class, the assignment looked like they were supposed to make a user interface with a brake button, a speed up button, and a cruise control button. So you add 3 buttons to it, and then you would make the commands. When the button is clicked, it's going to call these functions. So we can scroll up and look. What is button add? Scroll back up, scroll back up, scroll back up. Right now it doesn't do anything except print add button clicked. Update doesn't do anything except update button clicked. Delete doesn't do anything except that. But we're gonna fill this stuff in. It's going, as we go along, the application is going to become more and more full featured. Now all of this stuff about the pack command and what a string var is and stuff like that, what a grid is, we're going to kind of skip that for now. What I really want you to know is that when you create buttons, you specify the text and you specify the function that it's supposed to call. The other thing we're going to talk about a lot is something called a list box. The list box is going to be that scrolling data field in the bottom. And when somebody selects one of the items in the list box and then clicks a button, we need to figure out which item is selected. We need to be able to pull out the index value. So if they're on the top item, it should return a 0. If they're on the second to the top item, it should return a 1, and so on. And these concepts are common through all sorts of user interface libraries for C++ and Java and stuff like that. This is not Python specific ideas. Of course, the implementation is. So there is a function called refill list box, which wipes out the list box from beginning to end and then goes back in and sorts through our data, which we saw at the very top, which is a list of names like Lara Croft and Darth Vader, filling the list box back up. And then way down here at the lonely bottom, there's some code down here that says x is equal to input, and it asks whether you want to run main or run the test. If you type in 1, it runs the main, which creates the GUI and does all that stuff right here. It makes the window, it refills the list box, and then it calls main loop. Main loop is a method of that window which sits there and runs over and over waiting for you to click or to type. Or you can run test, and all test is code that exercises those methods for modifying our data. Remember up at the top we have list add, list delete, list add, list replace, stuff like that. Well, after we call list.add, that should append Buzz Lightyear to our data. Then when we call list delete 0, it should remove the first item. Then when we add Winnie the Pooh, there should be another item at the end. And then when we do list replace 0 Lara Croft, the first item that was left after we deleted the first one should now have that new data in it. And then we're going to print the data out. Now right now, list.add and list.replace and none of that stuff actually work. They're just empty methods. So when we run this, if we tell it to run that test, we're not going to see that it does much. Let's run it and see if we've got any syntax errors. Okay. It prints all of our data. Sarah Connors is the first item. Cara Thrace is the second item. When we get this working, Sarah Connors is going to be deleted from it, and Cara Thrace will have been changed to whatever we said it was, Buzz Lightyear or something. And then there'll be a couple of more data items added onto the end of it. So that's the first thing to do. Let's get this test stuff to work. If we look at it, the test stuff calls these functions. It calls add and delete and replace. So we need to scroll up to the top and modify that code. I could wing it, but I'm instead going to minimize the errors by looking at my last implementation of it. But really, this is not too hard. How do we add to a list? We do .append, I believe. Isn't that it?
Yes.
So we could just make it as easy as data.append name. Be kind of nice if we printed a message out too. Print .. added common name. Why those hashtags? Just to make it that data, that print statement really leap out. So hopefully this one is done. We'll double check it. All right, here we go. List delete. We need to delete an item from the list. Honestly, don't think we've done too much of that in this semester, but we can do it pretty easy. Delete data at that specific index. That will remove it from the list. and let's print pound, 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 deleted. Now we don't know what data was stored there. We're just referencing it by its index number. We don't know whether it was Joe or Bob or whatever that got deleted. So let's retrieve that data and display it before we delete it. So when we print # deleted name, we actually don't know that name yet, but we can get it real fast. So on that line above delete data, I'm going to say name is equal to data at the specified index value, like that.
And if it deletes it, was it going to print after you delete it? If you try to print name?
We have created the name and stuffed some stuff in it, so no matter what happens here, we still have that.
Oh, okay.
It's like we hand the football off to player 2, and then we tackle player 1. Player 2 still has the football.
Gotcha.
Maybe this one's done. All right, here we just need to, just like when you're changing the first letter, the first item in a list, data at the specified index is equal to name. This stuff should all be very similar to what we've already been talking about with lists. And let's print a message. Print #, #, updated, quote, comma, name, comma, at index, comma, index, like that. Give ourselves lots of debug information. And that one may be done, but we need to check all of these to see if they're done. We need to actually try them out. We will run the test again and see if it does what we want. All right. So I'm going to run the test. I'll bring that code back if you were going to snap pictures or whatever of it. Added Lightyear Buzz, deleted Sarah Connors, added Winnie the Pooh, and updated Laura Croft. So what did we have originally? Let's look at our data up originally and then check to see what it got changed to. Sarah Connors is gone. Cara Thrace got replaced by Laura Croft because element 0 was updated. And then we tacked on Winnie the Pooh and Buzz Lightyear at the end. So it looks like those functions are working. Looks like we have stuff to manipulate the list. It doesn't do any advanced error handling. If you specify an index value that doesn't exist, it'll blow up. So in our code further down, we're going to take a little bit of care to try to make sure we're not passing bad index values into it. But I think we can change these done question marks to done exclamation marks. All right, this function down here was weird and complex enough that I'm not making us type it in. It's already there. This is the function that takes whatever they have selected in the list box and returns the index number for it. So if they have the top line selected, the top name selected, it'll return a 0. And it does that by calling a function called cur_selection, which stands for which cursor selection, which line is currently selected. And it's a bizarre beast. It returns a tuple containing both the index number and then pieces of data about that. Something to that effect. A tuple, did we talk about tuples?
Yes.
A tuple is just like a list except you can't change it. It's returning a tuple. What we do is we see if the return from this function has any data whatsoever. If it's of length 0, nothing was selected. So we don't have an index number, so we're going to return -1. We don't want to return 0 as our error code because that means that the first item was selected. So they hit delete, they don't have anything selected, and we remove the first item. That wouldn't be correct. But if it did return a tuple, then the first item in that tuple is the index number of that item. So we're going to return that. So that's what listbox underscore index does, is it queries the list box, gets which line is selected, and returns the index value of that line. Why? So that we can, replace line 1 with some new data, or so we can delete line 2, so on.
And it really doesn't matter what's in the data box. That is just the command to do it.
To get the index of it, right. This function has no idea what that data is in the list box. Right. Just like these functions have no idea really once,
What's it
what
replacing?
was in the list box, and we've appended some new data, but we don't know anything else about it. Okay, so we have button add, button update, button delete. Let's run the program again and choose main rather than test, just to see what it does, see how far we need to go. It says making window
And nothing.
and nothing. Ah, there he is. If you close enough things, you see your little application.
Oh, awesome.
There are 3 frames. Not that we can see them, but the top frame contains the word name and an input field. Some environments call that a text box. Then the next frame contains our 4 buttons. And then our last frame contains the list of names. So let's delete somebody. I'm going to choose King Arthur. Delete him. Well, sure didn't delete him, but at least it said delete button clicked. We're going to type in somebody's name up here, blah, 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 and click add. Again, it says add button clicked,
Right, but it didn't add it because our buttons aren't made.
Right, they are empty methods. They're not doing anything yet. We will make them do something.
And dance. I think you're too long today.
So what is the add button going to do?
Append to the list.
It needs to find out the index. No, it doesn't. It needs to read the data out of that text box and then call list underscore add with it. So this is like the easiest one of them. It doesn't care about the index value at all, so it's not going to be hitting this function, listbox index. So let's get the name out of that name box, which was called name var here. I think I would have called it something else if I'd given it more thought. Name var is the text box where you type in the name, and it's created down there in that stuff that was creating the frames and the buttons. I'm going to scroll down there. Actually, I'm just going to do Control F and look for name var. We will see where it's created.
Is that .get, is that part of the toolbox interface?
Yeah.
Okay.
Right. So right there, it creates something called string var. A string var is a string that's embedded in your graphical user interface. And it gets added to the frame right there. And the position of it gets specified there. Anyways, we're going to go back up here. Very good question. Where in the world is this .get come from? It's a method that's attached to the name var. So we have a name.
So now we need a pen name.
We could just do data.add, but instead we're going to call our fancy list underscore add and pass that name in.
We can that now.
And then we need to call refill underscore list box. We have new data, so we want to refill the list box, get all the new data. We're actually going to change this function in a minute. You'll see why. If you go down and look at refill list box, the first thing it does is it sorts the list. So no matter what, we just add a new name. We want that name to appear sorted in the list, so we sort it. Let's run it again and choose main.
Unexpected syntax. What did you do?
I'll bring it back up so you can compare. All right, I'm going to click add. Oh, it added a blank line. It added another. It added another. I don't like that. I'm going to put an if statement. If the length of name is equal to 0, don't bother doing this stuff.
It's a little hard. I don't think I'd want to run that program ever.
No, teaches you a lesson.
All right, so once we get the name, we're going to do if length of name is greater than 0, colon, add the name and refill the text box. We don't need to refill the text box if we didn't change it, so that's why both of those are indented under if. Did you spot your typo?
Yeah.
Okay. I am going without asking y'all if you're okay. Please stop me if you need help fixing a typo before we go on for 15 more minutes.
I put a one space in, and it was saying that it was an indent. And I'm
Yeah.
like, no, that doesn't work.
Yeah.
So, okay. So do we need to make an else statement for that if it doesn't?
Yeah, you could make a print error, but I'm just going to leave it alone.
Okay.
So run main. I wish it brought that thing up to the front. There's probably a way to make it do that automatically. I'm going to click add. It doesn't do anything because there's no data to add. So I'm going to type in Charlie Brown and click add, and hopefully it will show up. Now the name is sorted by last comma first, or not sorted by, but that's how these are displayed, and then whatever we added is not modified in that effect, but that's fine. So Charlie Brown is there between Arthur and Connors, so that worked.
Oh, because I didn't capitalize it.
If we wanted to make it fancier, when you clicked add, it would clear out this space so that you wouldn't accidentally be adding another name, the same name more than once, like I'm just doing right here.
Oh, Charlie Brown.
We're going to leave that alone. Feel like putting an else there? Sure, why not? They're not supposed to see that stuff that's scrolling in the background, so I don't feel like putting a message there. I'm going to leave that alone. But I consider this one done.
Done it up.
Update. To do an update, we both need to get that name, just like this, and we need to get the index number. We haven't done index numbers yet, so let's skip update and go down to delete. Once they click delete, we need to see if any of the lines are selected. So we're going to call listbox index, which will return the index value. We talked about that. Checks the list box, see which line selected. If none of them are selected, it returns a -1. So index is equal to listbox underscore index, parentheses in parentheses. We need to make sure it's a valid index and not -1. So if index is greater than or equal to 0, because 0 is a valid index, it's just the first item, then we want to delete the element at that index. And then we want to refill the list. Am I expecting y'all to be able to go and write a GUI program after we do this exercise? No, but it's kind of like we're filling the swimming pool, you know. We're getting the data in our mind, and then we're going to go, you know, and learn the backstroke or whatever. That's a stupid simile, but you get the idea. Let's see if this works. And again, we could print an error message saying no item selected. I feel like doing that. I don't know why I didn't up there, but else
Consistency.
print no item selected for deletion. We can go back and modify the add button to do the same. Else colon print no data to add. So I went back to the add function and I added these 2 lines for consistency's sake, just to print out a message if they didn't type in anything but they clicked add. And then the rest of our changes we just made here. Try it out, run it, select a line, delete it. Then don't have anything selected, like by clicking in the text box and click delete again and see what happens.
You can't undo delete, huh?
Nope.
Control Z.
Control Z.
We could implement it.
Yeah, do Control Z.
That's a bit beyond.
It's going much.
All right, I can't find my window.
It's not gonna do.
Nope, we didn't save mine.
All right, there's our window. I'm going to click delete with nothing selected.
So is your Charlie Brown in there?
Not from last time. If we wanted to preserve Charlie Brown after we added it, we would need to be writing that out to a file. And then we could read it back in the next time the program ran. So anyways, when I click delete, it says no item selected for deletion because of our cute error message. But if I select King Arthur
Oh, that's neat.
and delete him, he disappears from the list. All right. Now, nothing's there unless I add something. Snoopy. Add a couple of copies of Snoopy. So far, so good. I consider the delete button done.
Done, diddly done.
You're not supposed to be here. Go home. Or was it Wednesday you said you weren't going to be here? Oh, okay. All right. You're allowed to be here then. We'll print it out and you can enter the rest of it. So button load. What button load is supposed to do is get the data from the list at the specified index value. So it's going to look a lot like this. It gets the index, and if the index is greater than 0, it's a valid piece of data, and it fills in the text box. So I'm just going to copy those two statements. Index is equal to list box index, and if index is greater than 0, I pasted it into button load, and if the index is greater than 0, we're going to get the name out of the index. Name is equal to, this is the one place that we actually didn't make it a method up above, a function up above.
List.
It's not called list, it's called data. Name is equal to data at the specified index value. And then we need, do you remember the name of our text box? No pun intended. What the name of that variable was? Name var dot set. Changes that to be the name that we just read in from our list. Else, colon, let's just do name var dot set, no data selected. That's kind of stupid, but it'll fill in that text field with no data selected. Then they're going to click add, of course, and it will put that message in as the name. So this is a really stupid thing to do.
Oh, it's gonna put it in?
Well, if they click add after, you know. So making the window, we're going to click load, but nothing is selected. It says no data selected. So I'm going to choose Arthur Dent and click load, and it puts Arthur Dent's information right there. Now, presumably, this would have a lot more information than just, you know, a name. There would be other information that we have loaded from a file or whatever, ages or classrooms or whatever. So the user fills up their data with no data selected, and then they get angry and they call us as to why that's there. So that wasn't a great idea. What we should implement would be an error message field down here, or a status message field that we could update, with useful messages. Because printing stuff out here isn't useful. They don't want to be checking a scrolling text window to find out why their delete key is not working. So we should implement a status field. We might do that another time.
So we need to get rid of that name var set.
Yeah, I'm not thinking that's a great idea. It was kind of neat looking, but let's instead just print no item selected for loading. I'll be right there.
I just have a question. I'm
Sure.
not really understanding what the load button is supposed to do.
It's supposed to take the selected line. Here, let me show you. And make it pop up into that text field. So I'm going to select, right now there's nothing in name. I'm going to select Arthur, click load. His name appeared in the text field. Presumably this would be populated with more fields than just name to be of any use. Names and phone numbers, or names and addresses, or whatever. That makes sense?
Yeah.
So the way the load function worked is it gets the index number of the currently selected line, and if it's a valid index, it gets that data and calls nameVar.set, with nameVar being the name of the variable that's tied to that text entry box. All right, that one's done. I think we've done them all except for up here. What did I skip? Oh, update. Yeah. So what do you have to do when we're updating? Let's run it and talk through the process before we just start making changes to the code. And then we're going to flowchart this. No, I'm kidding. Let's. Okay, so the way update needs to work is if we select Arthur Dent, type in something new, Lancelot, and then click update, it's supposed to change that entry from Arthur Dent to Lancelot. So it's going to replace that data.
So basically, if you misspelled the name,
Yeah. Be kind of a save. The way it really ought to work is as soon as you click on a name, it ought to fill in that text field with it.
Yeah, that's what I was going. So
Yeah.
Could we just load it into it?
Yeah, we could get that to work. Are we? I don't know. I don't think so. We'll save that.
we can charge them more if we put a load button.
That's right. They have to buy the expansion kit.
That's right. $9.95.
Wow.
Downloadable user content. Okay. Index is equal to listbox underscore indent. We need to get which number, not indent, listbox underscore index. If it's invalid, we're not going to do anything. So if index is less than 0, let's just print out an error message. Print no item selected. Then let's clarify if the length of the name. I think we should do this in the opposite order. See, this is what happens when I wing it. Up above this if index statement, let's also get the name, just like we did for add. We're going to read from nameVar the name that we want to update. So name is equal to nameVar.get. So the first line validates that we have a valid index. As long as the index is not less than 0, it's a valid index. So then the next one's going to be an elif. Length of name is equal to 0. That's also bad news. We're going to print no name entered. And if neither one of those error conditions is true, we're good to go. In which case we call data underscore replace, and we are replacing item index with that data. that name. So just to check, I'm clicking upload. That didn't work. Peter Parker. We're going to update Peter Parker with David Banner. Click update. It didn't work. Alrighty, I'm wondering if I'm getting error messages that I don't see over here. Yeah, all over the place. Data replace is not defined. Okay, what do I really call that method? List underscore?
It's called a list, list replace. Because
Yeah.
You said you made everything list.
My
instead.
mistake. Change data underscore replace with list underscore replace. I should do a search and replace once this is done and replace all the occurrences of list underscore with data underscore. But meh. Oh, I ran the test rather than actually running main.
So much time. This keyboard and me are about to fight.
Wait, what is the Hulk's name? Is he named Bruce Banner or?
Bruce Banner.
Bruce
Unless you're watching
Banner.
the TV series, then it's David Banner.
Oh, okay, that's why David Banner was stuck in my head. Update. Still didn't work. Still says Peter Parker. That's because,
So
okay.
I can't beat
I'm not going to tell you what's wrong. I want you to tell me what's wrong. Looking at this line of code here, button update.
And then,
What did we not do here that we did in this code?
we didn't refill the list.
Exactly.
Right, right.
So after list replace, do refill underscore list box.
Are we just, okay, just call on it.
And I think it worked. Peter Parker disappeared. Bruce Banner showed up.
That's update, right?
That was update, right. If we delete that and click update, nothing will happen instead of it blowing up, which is what it was doing when I was writing it earlier.
Oh yeah. It worked.
I don't think mine is working.
Mine's not working.
Yeah, mine's not working.
Alrighty. Time to pause the recording and walk around. I'm going to print this out for you.
That's
Oh, we were supposed to refill the list. Oh, did I put it in there?
you put a double equal sign.
Put it under delete instead of.
Really?
Oh, right here. I'm missing
JavaScript is like going on a style for HTML5.
No. Everything you do is through JavaScript. All of the interactivity.
I'm probably mistaken.
You use libraries. Java, as something that you download and run on your personal machine, is kind of being minimized because a lot of people don't want to run the Java plugin anymore.
Probably that.
But Java behind the scenes is a server-side thing. It's still going like gangbusters and just writing software within a company for that person to load and use without a Java plugin. That's still a common thing as well. So the idea of persistence, you were asking what happens if you append the data. That's what files are for, persistence of data. So we've seen how to open the files. What's the difference between opening a file for reading and opening a file for writing? What's the syntax for opening a file for reading? I'll give you a hint. It's what I've highlighted there.
It's that right there.
So opening a file for writing, what do we do to change it?
Don't you just add on a comma and then put W?
Yep.
So what if you put R? Does that just do the same thing for read or?
Yeah, let's try it out, but that is true.
But if you just open the file, it just automatically opens it for reading?
Correct,
Okay.
correct. So I'm going to call this one file 3. Whoops, I already had a file 3, excuse me. File 4. And all it's going to try to do is open itself. F is equal to open file4.py, comma r. Let's just see if that works.
Run.
It didn't produce an error, so if you don't specify anything, it assumes R, but it's also okay to specify it.
So you can open, oh, could you go back up real quick? Sorry.
Sure, sorry.
Open, close, open.
These are not the order in which you would do things. You don't close the file before you read or write.
That's why I was like, that's what I was looking at. I said, what is wrong
Yeah.
with that?
The return value from an open command is called a file handle. So FH is our file handle. As long as the file is open, we can do things with it via that file handle. Once we call fhand.close, then we can no longer modify that file through that handle.
But there's more parameters for that besides read and write, right? Isn't there like a
Turn it to binary.
Right. These are opening them as text files.
Right. There's also the compared that you're adding. Raw.
All right. It does not go very far in talking about writing out anything other than text. So let's go look.
I saw X too.
Well, firstly, let's hit the PDF rather than the online file. Nope, that's all they do. Okay. Think like a computer scientist with Python 3. That's the one we used last semester in 1113. And here we go, binary files. Files that hold photographs, videos, music files, executable, whatever, are called binary files. You can't open them with idle or notepad or whatever and see the text in them because, you know, they're not in text format. They're not in ASCII text. So to do that, you tack on a B.
read binary and write binary?
Right.
How would you write to a picture?
Well, you'd have to know the format of that you needed to write out to. Image files have a very specific header, and then the data in them is compressed in a very specific way. It's encoded in a specific way. Your app would need to know all of that. So here the author has written an application that's supposed to open a file, open another file. It opens the first file for reading as binary. It opens the second file for writing as binary. It reads in up to 124 bytes at a time. And then it writes those, not 120,024, and then it writes those bytes out. And then if it ever called read and it didn't get any data, it's at the end of file and it breaks out of the loop.
So basically it's renaming that zip? Or
Well, it's not renaming, it's copying it to a new one.
Yeah, that's right.
So let's go back to our file 4 code. I'm just going to comment that one out. That one's not too exciting. Actually, yeah, let's do it. Except we're going to read it as a binary file. So fn is open file4.py rb. And then fout is equal to open file4.py.text. We're just going to create, let's give it a different name. File4 copy.text, comma, write binary. Going to use a classic while true loop. While true. They use the word buf. You could call it anything, but it's going to be a buffer containing a certain number of bytes. They use 1024 because that's a K. You could read in more than that at a single time, or you could read in less than that. So we're going to do the buffer is equal to fin.read. Let's read in a K just like they're doing. And then if the length of the buffer is 0, then we are at the end of the file and we may as well break out of our while loop. Otherwise, and I'm not going to add an else because if you haven't broken out of the file, the else is kind of implied. Fout.write our buffer. Then we want to close our files. fin.close, fout.close, and then let's print done. The reason I made it file4.py is because that's the file that we're currently editing here.
Oh, so is that this is supposed to be file 5.
All right, it doesn't tell us what it did. Let's add one more message. How many bytes were written out? Printf wrote, comma, len buff, in parentheses, comma, quote, bytes. Just so that we can see if it's doing anything. Wrote 256 bytes. This is a short program. It may very well be 256 long. Let's go to the directory where our scripts are stored and see if this backup, this file that we created, is there. File4 copy.txt, I can double click on it. It should be a carbon copy of this file. But since it's opening it as a binary file, it could be anything. We could open a JPEG and we would be making a perfect copy of the JPEG. Whereas if we tried to open it as a text file, that would not work at all. So you can read in a file in one fell swoop, one great big read, or you can read it line by line.
Quick question.
Uh-huh.
Since we're still dealing with the Python files, do we have to use the binary part, or can we just read it?
No, but since we're dealing with PY, the B is superfluous. They're text files. We could open and write them out as text files, and it would behave just fine. But if we change this to .mp3 or something like that, then it would not work unless it was a binary. So let's open our self again, file.py. fin is open to file.py, and we're going to read in absolutely everything. I'm not doing it as a binary file. BUF is equal to fn.read, parentheses in parentheses. That just reads all of it into one file. And we're done. We can close it, we could process it, we could write that, we could do whatever we wanted to it. So then fin.close. And we may as well print that buffer out. Buff equals, comma, buff. That is an example of reading the whole thing in one shebang, except it didn't work.
That's all I was gonna tell you.
File4.py. All right, so there's our buffer. From here to here. We read that in all with one swoop. If the file was a couple of gigabytes long, that probably would not be a good way to deal with it. That's why they did it this way. We read in a certain number of bytes. If it's a huge text file, reading it in isn't really appropriate. You would want to read it in line by line. So let's do that. Let's comment that this is read the entire file with one call. That's what that code did. And this is read the file line by line. FIN is equal to open. Same file, unless you feel like specifying a different one. And then you use a for loop. For data in FIN colon, print just read colon, comma, data, or processing data. Some text here that's make it easy to spot. Processing data. And then we will close it. fin.close. And here we get into that business of where we should have stripped the data, because that's pretty ugly.
In the bar graph assignment that we did, mine would replace the spaces with, or you know how we.
Oh, that's right. That's right.
Replace and then you, yeah, that.
Yeah, let's work on that. In fact, here would be a good place to do that. But I do want to fix this part first. Let's do data is equal to data.strip. That'll remove the spaces at the end. It'll also remove the spaces at the beginning, unless I just do rstrip. Strip everything on the right side. So if we want to preserve the indentations, I'm going to make it rstrip. That way we won't get the blank lines. That's better looking. Okay, so here we have a great big buffer. Right here above this line that says read the file line by line, or we could put it down here. Let's try to replace all the spaces with periods. You know what, I better look this up. Or I could look at what we did last time. Okay, so new buff is equal to buff dot replace all occurrences of space with periods, and then print new buff. Let's see if that's going to work. Looks like it did.
Yeah, and works, like, and I ran it in the shell, it worked, but when I tried to do it in actual code, it didn't.
What you may have been doing is you may have been calling .replace but not storing the results back into a variable.
Yeah, that's
So
fine.
if we wanted to do that, if we wanted to replace the original data, we would do that. Buff is equal to buff.replace.
That's probably what I did.
So if we made buff.replace a space with an empty string, that would strip out all the spaces from it.
So,
So why did we demo that? Because the assignment from Wednesday suggested that you remove the spaces from the document. Don't have to.
that would be the one I missed.
All right, guys, let's call this done. We have 2 files to upload. Make a Dropbox. Alrighty. So we won't assign homework from today since y'all are still working on other assignments. Wednesday, we'll do something else. Yes, sir.
Can you pull that code back up?
Sure, the file one? Okay.